Hi, everyone. Welcome to the July edition of Ask SAP Live Chat. Joining me this month are Eric Vallo, Managing Partner at EVI Technologies, and Greg Myers, Solution Director at EVI Technologies, as well as Timo Elliot, Global Innovation Evangelist at SAP. Now, I look forward to all of our live chats, but I'm looking forward to this one in particular, in part because I love Tech for Good. They're my favorite analytics stories, and Greg, Timo, and Eric are going to cover a couple of these as they talk about changing the world with predictive analytics and machine learning. Now, as with all our live chats, you're welcome to ask questions at any time, so don't be shy. Simply publish them as a comment on Facebook, and we will get to them throughout the live chat. If by chance we don't, we'll make sure to circle back and answer any questions via the commenting feature. And if you are catching this on a replay, you can still ask questions. Just again, use the commenting feature and we will circle back and answer. So with that, I'm going to turn it over to Timo, Greg, and Eric.
Thank you, Avery. And so let's dive right in. Let's talk about in changing the world. But let's continue the intros just a little bit. So Eric, can you tell us a little bit about why you've been invited on this podcast and what EV Technologies is about? Where does that EV come from? I just can't work it out.
Electric vehicles.
Perfect.
We're a misguided bunch. No. I'm chief nerd at EV Technologies, and we help everybody with problems from ingesting data to how we predict upon it and make good decisions. So we're honored to be here today, Timo.
Excellent. And Greg, do you want to say a couple of words more on what do you do?
I'm the one that has to implement all the crazy ideas that this guy has. So, yeah.
Oh, sorry about that.
It's all right.
And I'm the guy who gets to talk about all of the crazy ideas that you guys implement. And there's one particular project that we have in mind that is a wonderful example of using predictive analytics as a force for good. But we will go into more details just about that just a little bit later. But let's start off with some basics. We talk a lot, there's a lot of confusion in the market about artificial intelligence, predictive analytics, and machine learning. So let's just start with a quick baseline of what we're talking about. What are these technologies? How do they work? What is the point? Eric, as chief nerd, I think that's what
I was totally going to point to Greg. Delegating. Delegating.
Oh, he's delegating. All right. Well, so that, yeah, you're right. There's a lot of buzz around these different terms. So, the predictive analytics and data science is nothing new. It's actually been around for quite a long time. Usually, historically, it's been in the realm of statisticians and mathematicians and really super brainy people that could do this stuff, manually. And it took a lot of time, but in recent years, we've figured out ways that algorithms can do it. So generally speaking, the way I like to explain it is that predictive analytics are these types of algorithms that help you discover information that you didn't already know, whether that's a forecast where you're trying to figure out the likelihood of something to happen, or if you're looking at, trying to find a pattern that's not detectable by the human eye in a very large set of data. So the predictive analytics part of that is a human doing that, experimenting with different algorithms. Machine learning is generally the same process, but it's a machine trying these different algorithms and learning on its own to try to figure these things out. So predictive analytics is a human doing this. Machine learning is a machine doing it.
Yeah, so algorithms that improve themselves based on the data over time. My claim to fame is that I launched a predictive analytics for the mass, data mining for the masses product called Business Miner in 1996.
Yeah.
It was a great product and a spectacular commercial failure. That I don't think anybody ever bought. And it wasn't because it doesn't work. It was really because the background was just not ready. People didn't have enough data maturity about the understanding the complexity of it. But above all, they didn't have enough data. And didn't really have enough power to really churn through the big models that we have today. So more data, more
a few years into the data warehouse arms race before it was ready.
Right. Yeah, no, basically. So now, a good, 20 years later, now it's coming back. This is a tipping point, clearly. We've got enough data, we've got enough power that we can really start doing some amazing and interesting things with this new technology. So the theme of today, obviously, is about how do we use that to change the way the world works, to improve things. So how does that work? Eric, your turn this time. At a high level, what could this do to help us?
Oh gosh, customers are starting to ask lots of interesting new questions. The reality that Greg was talking about and that you referenced from 20 years ago is PhDs in large part drove how we tackled data science and what we thought we could predict. And the idea of predictive analytics is allowing the business to think through two key things. Can I do something to incrementally generate new revenues or simply avoid costs? And so that spans all fields. We're talking to customers in healthcare, sales teams, website click patterns, and ad placement type of activities. And it's interesting, right? There's something in it for everyone. And
I'm not sure that ad placement really counts as making the world a better place. Not directly, anyway.
I was speaking generally, first of all, right? But more specifically, our projects and one of the topics of today is in how we've been using predictive analytics to improve and better health outcomes.
Okay. We're going to go into nice cases. So I think there's two levels, right? So first is efficiency. We can do stuff that we did before, but we can do it faster by delegating some of the decision making to the algorithms. So making complex, repetitive decisions. The other is augmenting what humans can do by giving them more power. And it is kind of related at one level. But I think that's the big opportunity. So business as a purpose. The background of this is really, this technology is incredibly powerful stuff. It's amazing. It can be used as a weapon, or it can help improve the world. And basically, a lot of the best run companies help the world run better. A lot of organizations are realizing that one of the nice things about modern technology is it can be win-win-win. You can improve efficiency, improve revenues, improve business, and also make the better place world a better place. So that's what we're hoping to get to here, is encouraging people not to think a little bit outside the box, not just what their primary mission is, but maybe they can also, while they're working on that primary mission, help improve some other areas. So why don't we just go through your specific example in some detail, and you can tell us what you did and why it's so good.
I'll tee it up. If anybody listening had been to Sapphire, there's a strong message in the SAP ecosystem in how we improve how we run businesses on SAP's platform. And the customer that we attended Sapphire with this year took a stab at how to apply SAP to do just what I mentioned a moment ago, improve health outcomes. And the idea in their case was quite simple. They're a behavioral healthcare organization, HarrisLogic, based out of St. Louis, Missouri. And they've been in business for like 35 years. And they've been embracing technology and how to operationally improve how they use data and analytics to function as a company. But this idea that, well, with 35 years of history, can we begin to predict better healthcare outcomes? And we did just that. And so when you looked across the landscape of technologies, HANA was sort of at the underpinnings of that concept, and SAP Predictive Analytics, and Greg will be able to speak a lot more about that. But the concept was simple: can we take our history, can we take a sample of it, and can we predict what the humans that we've already cared for over that lifespan are going to do, or how they're going to react, or what those health events are going to be? And what we found was with sort of a surprising degree of accuracy, using the SAP platforms, you could do it. And that's where that conversation between automation of a predictive model versus assisted came to pass, right? Especially in healthcare, do you actually want to replace the job of a human being? No. In this use case, it was, how can we prescriptively tell a clinician the best possible information we can so that in real time they can take care of somebody in need? And it was pretty profound. And so when we put it all together, a new approach to a user experience for the clinician that gave them lots of the same facts that they had been consuming over the years, but then these predictive models that appeared as a facet of that user experience, and now they're armed with new decision support tools to fuel how they interact with those clients, those patients.
We're talking at a fairly high level to start with, but can you make it more concrete? Like, bring it down to a concrete, if theoretical example of exactly how this technology might be used. So what might go wrong, and how could predictive technologies help stop that from going wrong?
Of course, in HarrisLogic's case, their primary function of their business model is how do they keep people with behavioral healthcare problems out of the jail population? It's a terrible treatment mechanism because they don't get the care they need in a general jail population, and there is no continuance of care. How you avoid future occurrences of a behavioral health crisis. So in ingesting this data,
so this is a mentally ill person who's acting crazy in public. Nobody really knows what to do. Ideally, they would get some mental health specialist to help them. We don't have those people on 911, so that the police turn up, do what they can, but inevitably they end up being pushed towards the justice system a lot of the time, when perhaps the mental health care system would be more appropriate.
That's right. I think the quote I saw from HarrisLogic was a 3-day stint for someone with a behavioral health issue in a jail population is like a $12,000 expense to the taxpayer. It's incredibly expensive, and they're not getting any treatment or care that they need. And it's a scale, right? It's everything from depressed to angry to even suicidal, which puts them in a high risk population too, right? So through a combination of both clinical services as well as technology services that are integrated with the state and local government, and ingesting all this data about these clients and their care, they're number one. It's two major things. One, intercepting people that are having a behavioral health crisis, and number two, if someone has been introduced to the jail population, getting them out within hours and into the right clinical care versus them wasting away in a jail cell where they're not getting help.
So Greg, maybe I can turn to you. So I talked about this example in the past, and a lot of people are very surprised that the data was available. So what data sources did they use, and how did they get access to such sensitive data?
Yeah, that's a great question. So that's actually another part of the business that HarrisLogic runs. They have crisis hotlines, where suicide hotlines. So they had access to a lot of that data too. And then working through the local prison systems, they were able to aggregate a bunch of data that came from past bookings, and we were able to kind of mash all that together into this one master set of large data. And you're right, it is very sensitive. So, the
security. But the bottom line is they didn't snatch it off the street. They didn't.
No, it's all stuff that's all
black market. Data they had rights to because of the other things they were doing. Exactly. They were allowed to bring it to data. They respected all of the controls necessary to do so.
Correct.
Okay, yep. So they put all this in one big predictive model, but data doesn't do anything. How do you actually turn that data model into an actual better outcome?
That's another great point too. So, in that sort of concrete example that Eric was sort of talking about, the clinician now has access to this application, and all of that data sits behind. And the clinician doesn't know what's going on in the back, and nor should they. That's not their job. But with this, it on the application, it looks like a tiny little thing, but it's actually probably the most significant part of the whole application. There is a number there that tells them what percentage of risk this person is to go back into the prison system. And that in and of itself is where the big cost savings comes. And it's so much better for the person that can drive a better outcome when you know that likelihood within a very high degree of confidence that this person's at risk. So again, on this clinician's interface, like you said, they come in, they don't.
Just to say, so who is this clinician? Is it like my local GP? What does a day in the life of this person look like? What do they actually do?
So part of HarrisLogic's specialty is they're one part clinicians and one part technology company. Right. They have a crisis call center that specializes in everything from, hey, I'm depressed, I'm off my meds, help me, to I'm feeling suicidal. And so there is a call center that focuses on helping people in real time. They have mobile crisis units that can go out into the field and actually intercept people and interact with them and help them. Okay. And that's why on HANA, we built a native responsive application that can work whether they're sitting at their desk, at their office in the call center, or on their cellular equipped iPads. And it integrates everything that's happening from the data that's streaming in to the predictive model that was built and put in HANA to execute in that view.
So these are people in mobile response vehicles. Do they get to put the siren on?
Not that I don't know. You've pushed the limit of my understanding, Ted, but that would be awesome.
So, but their job is, so they do have that first responder role. And okay, so getting back to this dashboard. So you said there's this small little number that's super important. So that number is what? Is the risk that they're going to do something? Is do they know when they're going to do it? How?
Yeah. So the industry term there is recidivism. So that's the to go back, these people that keep going back into the prison system in this closed loop. And then there's a high utilizer piece of that as well as the other calculation. And that's people that use lots of services while they're in, and that costs a lot of money. So knowing
the drunk, crazy, homeless people for whom the system just sort of ends up putting them in jail every now and again, and they get,
round and round and round.
I saw there was one guy who had cost like millions somewhere. They worked out they could have bought him a mansion with the money that he ended up costing emergency services and things.
Exactly. And so having that risk factor identified for the clinician as they're talking to the person in real time, that can help them drive that treatment in a different way that breaks that loop of them keep going back into prison, get them the care they need, keep them out of the prison system. It's better for everyone. It's better socially for that person because they're going to start getting the care that they need.
Now, I heard that there were two numbers of reliability of these models. One was at 95% and one was 99%. So what was the difference between those two numbers?
Well, there are different calculations. So, right. So the recidivism calculation, the degree of confidence on that is like 95%. And then the high utilizer, we were able to tune that algorithm to it's 99% accurate.
That's amazing.
It's important to qualify, though. There's a couple of ways to look at those models. The first is, and the highest accuracy were the people that didn't need intervention. Because if you're thinking about the allocation of resources based on taxpayer dollars, knowing where to allocate time and people is just as important. And so when we think about the people and the levels of care based on that algorithm, those that show up in the high risk models, even lower accuracy gives us a better opportunity to provide them care that they need on time and keep them happy and healthy.
Can I hazard a guess that HarrisLogic doesn't have money to throw out of the window and needs to figure out what to do with their limited resources? Just as a guess.
Well, I think that the reality is this it's a national crisis, right? I mean, this problem exists across the entire country, and it's sort of a niche problem, but it's created new opportunities for HarrisLogic and the application of SAP's data platform and SAP Analytics that in ways that we didn't necessarily anticipate. The fact that we created a new native app on HANA has allowed for this new partnership for them with the Zero Suicide Institute. And the Zero Suicide Institute is really well known for their methodologies in dealing with people that need a different kind of care, right? And so through that partnership, we're going to be able to weave the fabric of their workflows into an application that can be integrated, and we can use their historical data to improve our models as well. And then the second is this incredible statistic that like 1 in 3 students in the higher ed world are suffering from these same behavioral health crises that those being introduced to the jail population are, if you can believe that. And so we're looking at how we apply this technology at the academic world to help students and student populations have a healthy educational experience as well.
So overall, it's an amazing opportunity. We're using the data and the analytic model to do more with less, take the existing limited resources and focus them on where they are most likely to be needed. We're helping mental health patients and saving the communities and taxpayers a lot of money. So win-win-win, which is, again, the theme of the show today. But is there any downside? The other thing that comes to mind is the whole Minority Report thing. So what happens if there's a false positive, or do I get swept in and sent to a mental institution before I've done something on the street?
They plug you into the matrix. And, I think the words trust but verify sort of come to mind for me, right? Especially when you're talking about data and analytics and predictive analytics, when you're talking about the care of other human beings, do you really want that to leave the hands of a qualified professional? Like, would you want a machine telling you, do X, Y, and Z? I don't know that I personally do.
Right.
That's why I think organizations like HarrisLogic are smart. They're using it to augment the capabilities of their trained and qualified caregivers, so that they can be that discerning point of view in real time in how to help someone.
And presumably then their reactions go back into the algorithm next time around. So if it does come up with a false positive and they said, yeah, no, this person's fine, then that would go in and be used next time around.
There's a couple of components to applying machine learning to this model, right? It's that human point of view. I mean, also, did an event occur that we didn't catch and anticipate? Did they not get a clinician touch but still ended up in the jail population, right? We'll have that data to offset and improve our model over time.
Great. All right, let's do a little techie aside, Greg. So deep dive. What does the stack look like? If somebody wanted to do this at home on their own,
yeah, well, sure.
They install.
Actually, so
that's a really good that's a really good question to talk about, because when we did this as a proof of concept for HarrisLogic, it only took us 8 weeks to the end. So there was nothing really throwaway at the end. We used the HANA 1 image in Amazon Web Services, which is HANA for pay by the hour, which is really inexpensive. It's like, it ends up being $3 an hour to use, which is great. And when you're done, you shut it down, you're not paying for it. We were able to load the data in there and start exploring. We used SAP Predictive Analytics to train our models, and then we exported from the desktop tool that model as a HANA calculation view to sit on top, and then the developers were able to wrap that calculation back into the application that they wrote natively. So, all in all, it's that HANA image it's in the cloud that sat on top. They had the application built on top of that, and the data streaming into it. And we were able to do a fully functional proof of concept in 8 weeks. So it's not a huge undertaking. You can actually do it on a shoestring if you need to.
Fantastic. And let me remind the audience that you can ask questions at any time. And we have one here from Ramesh Babu. How far can organizations rely on predictive analytics for the sales forecast or strategic marketing? So a little bit straying off the topic of tech for good, but we can bring it back to tech to good. So how much can you rely on the algorithms? I'm in SAP's head office here in Waldorf, Germany, and I'm actually attending the Internal Analytics Day. So this is where I get to talk to all of the people doing the analytics of SAP's own business for our own 85,000 employees. And it's fascinating. We just did a session on introducing some of the predictive projects we've done internally to people, notably in finance. And the questions for the audience were all, well, but can we trust that? What can we do with that? What would be your reaction?
So I think it's sort of what Eric said before, I think, with trust but verify. So that these things are tools to have in your toolbox. They're not meant to replace human ration right yet, rationality, someone that can look at this and make understanding of it. So you talk specifically about like sales forecasts or that type of thing. So another use case we did for a sales organization of a big multinational company, they were skeptical of it as well. So we were looking at their targets to sell their products for a given month. And I said, well, what if I could tell you that customer and the top 5 things that they are likely to buy based off of their past behavior and other customers that are like them? So put that into a recommendation engine for them, and then when you take it down to dollars and cents, I was able to show them through the data, if your salespeople for 1 month all just sold one more thing off of that 5 list, one thing with like a 90 or between 80 and 90% likelihood that they're going to want to buy it, you make an extra $24 million this month. And who doesn't want to make an extra $24 million in a month, right? So absolutely, you have to go back and benchmark that. So then say, how well did we actually do with it? But just having that information as a part of the human's decision process, in this case, the salesperson, to say, but did you know you needed, we think you might need these, you might be interested in them.
Yeah, and just as an aside, sometimes predictive is a really bad term, because predictive, for most people, they think about the future. And it turns out the future is one of the hardest things to predict, because guess what? The world changes. It's actually much easier to use predictive in things like clustering. People like this did that. Mm-hmm. So it's a little bit what you're doing with a patient. And I guess this can affect the customer experience. It certainly has did for me. We worked with a large retailer in France. They sell electronics. They knew that the number one thing that they tried to cross-sell at the till, you go to the till, you got to try and pay. They say, hey, would you like a deal on this? And it would always be the insurance coverage on the thing that, on the device you just bought, to see if it would break. It's a rip-off most of the time. They make a lot of profit on that. So I know that, so I turned it down systematically. But that was a wasted opportunity. So now what they do is, based on the profile of the person, say, you know what, this person has bought 18 things from us. They haven't taken the insurance a single time. It's kind of stupid to offer that person the insurance. Let's offer him or her some other thing. So, but when you're buying a printer, say, would you like the free cartridges, the cheaper cartridges delivered to you as a service? But that kind of cross-sell can ultimately also improve slightly the customer experience, because you're at least not wasting my time.
If you think about it, like to put it into real specific time windows, right? In both the customer cases we've talked about so far, you have historical data. And let's just say, for the sake of argument, I have 36 months of data, 3 years. In both of these cases that we've mentioned, we took 35 months of history as the fuel for the predictive model, and used that 36 months to verify, right? Trust but verify. And by doing so, and then applying machine learning concepts, we create models that can continually learn based on those outcomes. You don't create a model once for 36 months of history and assume, I got it, this is going to be good for all time. It has to be something that moves along with the patterns and the trends of your data.
And this is a sign of the increasing maturity as well, is that everybody's realizing that you need to have a more factory approach. You can't have just data scientists creating bespoke models every time. There aren't enough of them. They're too expensive. It just doesn't scale. So you need to be able to generate lots of models and have them updated on the fly. Remember to ask any questions you have there in the audience. Ask SAP. I actually want to take, so in one level, we're doing sort of predictive of bad outcomes. And there's a whole other area where predictive is very common, which is predictive maintenance. Again, not directly applying, not often to people's customer experience, making the world a better place. But in some cases, we've been doing some interesting projects. We're working with Trenitalia in Italy. They run the national train system, the fast trains. But we actually worked on predictive maintenance for their trains. And it can actually have a direct effect on the customer experience. The example they gave, true example, was they were using these systems to detect the heat in the bearings of the train. And they managed to detect this just as it was halfway across the Tuscan countryside. So it immediately pulled into the next station. The customers all had to get off the train. They were grumbling. But they then had another train come up within 15, 20 minutes to take them through to their destination, to Rome or Milan. As they were taking the train that they got off of, as they were taking it for maintenance in the sidings, the wheel bearings seized up and it got stuck in the middle of the track, and it took hours to fix it where it was and get it to the station. So you would have had, I don't know how many people there are on a train, like 1,000 or 700 people stuck in the middle of the Italian countryside for 3 hours. So like,
sounds terrible. Bring the Vino.
There are worse places to be stuck.
Without any Chianti anywhere. But just so predictive maintenance can be a big thing, and I'm actually a big believer in this. Somebody said, well, what's the biggest area that this kind of stuff can help with? And I think predictive maintenance for people is a big opportunity. There's some research done by some folks in the UK, actually, where they created digital twins of heart patients. So they put heart patients in an MRI machine. They took 256,000 different measurements of their heart beating in great detail. They created a digital twin of that and then used the digital twin over time, the history of their treatments and how the heart reacted, to make predictions about outcomes. And they were 30% more accurate than the doctors alone. So it meant that you could get better treatment. Now, unfortunately, the final outcome for these patients, because they were terminally ill, was whether they were going to decease or not. But it's an example of what we can all help expand lifestyles. I'm personally looking forward to my Apple Watch or other name brand just beeping one day saying, careful, you're just about to have a heart attack. Please get yourself to somebody to look after you in the next
Apple Watch
10
does
minutes.
that, right? And
So,
introductory anyway in the heart rate.
Right, we're three middle-aged males, so this is statistically something that is high. Sorry, you're not middle-aged yet, Eric.
I was going to say, who you call middle-aged?
Easy. You don't know me.
All right. Again, keep your questions keep your questions coming. We like having people give us reactions, ask new questions, make sure that we're talking about things you're interested in. Do you have any other fun examples of areas where you've seen predictive provide good outcomes for the world?
There was an interesting story. I can't remember if it was in a book I was reading about predictive analytics or a course that I took about it, but I remember the story. It was actually very interesting. But as someone was doing some research on the most reliable type of automobile to buy, and it didn't come down to a brand, but what he actually found through his research was a car that was made on a Tuesday and was orange in color was the most reliable. It's like, who knows why, but again, that's why you need the human part too, to then dig into why. But through the years of historical data, if it was made on a Tuesday and was orange, it was the most reliable car to buy. So just one of those.
Well, that's kind of scary though, because then you're like, okay, well, what do I do with that?
Well, you need to figure out what to do with that, right? Obviously, but what are the factors in that? If I was a car manufacturer, I want to know why that is, and so I can make all my cars that reliable.
Well, actually, it reminds me of another story of the car manufacturer that had a predictive model to look at sales to figure out what models of cars they should be making next. But it went spectacularly wrong because they made a whole series of lime green cars. and these things just didn't sell. They got stuck on the lots. They were there for months on end. So somebody in marketing said, look, we got to get rid of these things. So they created a promotion where you got a really good, sweet deal on lime green cars, and they managed to get rid of them all in a short length of time. So guess what? The predictive model for the production wasn't linked to the sales algorithms or the marketing algorithms. So all they saw was a big spike in sales in lime green cars. So immediately started up the production for more lime green cars.
Yeah, there's another one that I knew about recently, and then we could take the question, but just real quick. I actually saw it on the national news a couple months ago, and I played around with it for a while, but there's an app you can get for your iPhone. I think it's on Android too, called RoboKiller, and it uses algorithms to predict if a call is a telemarketer or a spammer, and then it actually has an AI chatbot which will answer the call and waste the telemarketer's time with
just take my money.
Nonsense. Yeah, exactly, right? It costs like $30 for a year, I believe, but right.
That's a great example of predictive and technologies in learning, making the world a better place. I'm definitely
for the consumer.
Raising the barrier on spammers. Of course, though, what's dangerous is that's not going to be the number one use. The number one use will be the AI spammer that you can't tell is not a human and automatically adapts to you faster than the average human does.
Thanks, Google.
Yeah, right. It was Google that had the two AIs that invented their own language, that they let the two language AIs to talk to each other, and they had to unplug it because it started creating their own language they couldn't understand. Yeah. Oh, shut it off.
Somebody pull the plug.
So we should take the question here from Ramesh again. So how different is analytics when compared to reporting with special reference to ERP? Let me sort of translate that. So in ERP, we're used to just getting a whole bunch of standard data sets. Why isn't that good enough? Analytics adds what, and predictive adds what? Just like, what are the steps you see with customers?
A little off topic.
Hey, it's a question.
It's a question.
Yeah, let's be honest. If we're talking about SAP's business suite, it comes with sort of a one-size-fits-all approach to building an application. And have you met more than two businesses that run the exact same way? So, and who hasn't customized and created a Z table in SAP ERP? So, no, we ultimately end up in roles where we have to extract data and create new facts from it and new information that might be, using out of the box CDS views and enhancing them, or HANA Live views, what have you, SAP BW. But ultimately, while you might use embedded analytics and S/4HANA for sort of your inline embedded analytics views, but more complex assets like dashboards and data discovery mechanisms with more complex views for your analyst, the person that really needs to go deep and find the trends and the patterns that set them up to be able to create a prediction or anticipate, how am I going to generate revenue? How am I going to avoid costs? And that person with that true intrinsic knowledge of how do I do business and what data is SAP telling me, brings those two things together in an analytical world.
And I think I'd add also that just sorry, the lights went out because it's 5:30 in Germany, and so the lights go out, assuming that people have gone home, I think.
Get out.
The predictive only works if you have high quality data. You only garbage in, garbage out. So you have to have large quantities of high quality data, and that's the hardest thing with most predictive analytics projects. So I'd say the biggest link between ERP and what we've been talking about is that ERP in general is often one of the biggest sources of high quality corporate data. It's far from perfect, I'm sure, but it's a lot better than random spreadsheets that people have. It's been under control. People have paid some attention to going in. It's already being used for business uses. So building models on that is probably the easiest place to start for most organizations. Okay, we've got another question here for some industries, predictive outcomes are not accurate compared to other industries, e.g. consumer goods industries. It works well, but not for B2B businesses. How true is this? If not, then why? Okay, I could answer that, but let me give you two guys a crack first.
Yeah, I think it leans back to what you just said, and I'm not sure that you can bucket it by industry like that so clearly. It all has to do with the quality of data that you have. You know, some algorithms work well with certain data sets, and some they don't, and a lot of that has to be, you know, figured out through exploration. But it really has to do with the data and where you're getting the data from, less so than the industry. I
agree that the algorithms don't know what industry you're in. So yeah, it's more, that said, there are industries where it is generally being more applied because they have more high quality data and their business is ultimately selling data more or less. So finance and telecommunications. A lot of the time what they're actually doing is moving ones and zeros about. That's basically their business. Well, a phone call is ones and zeros, your money and what is ones and zeros. So predictive analytics is super important to helping them do that better.
Well, and think about data as a whole, walking from structured to semi-structured to unstructured data. Like as people, as practitioners of predictive analytics and analytics as a whole, we generally start with the stuff that's easiest and structured and our rows and columns, and we understand it. But as we get better at both the technologies and how to apply them, we take the other sorts of data that we can accumulate about, you know, notes and emails and website forms and the things like that, and learn how to extract relevant bits from that so we can improve our models as well. And
this is a really new opportunity because that stuff really does not lend itself to traditional types of analytics at all. Right. So one of the huge advantages of predictive is that it copes with, depending on the types of algorithms you're using, it can cope extremely well with structured and semi-structured data.
Yep. And a case in point, one of the areas that we're going with HarrisLogic next is in that 35 years of history, they have 35 years of clinical notes history. And who we don't even know, but having invested in HANA now, it's starting to work with the text analysis engine to start looking at, with our clinicians, what should we be looking to extrapolate from those notes? Because again, they know best, not us. We're the nerds. They understand their business, how to care for people, and the nature of the data, so that we can start to turn that into relevant information for them to improve the model. And guess what? We prototype a lot. Like we don't going in, we don't know if data is going to improve our model. That's why we prototype, evaluate, and throw away. And SAP PA specifically with HarrisLogic helped us do that. Quickly identify the relevant variables to a model so that we can move past the garbage and apply the data that matters to our model.
And so predictive analytics, just a high level, so we can improve efficiency. So whatever you're doing today, you can improve the way you do it. And if that's saving patients, then that's all the better. Because you're more efficient, you're using less resources. So if it's farming, for example, you're using farming more efficiently, then you're also helping sustainability, you're helping the planet. You can also use these new technologies to improve the customer experience. Again, just helping us all, whether it's being stuck in a train in the middle of Tuscany or being better service in a hospital. There are other areas, though. We'll get to your question in just a second, Prakash. Let me give you one fun example I had was another Innovation Award winner this year at as part of the Sapphire SAP User Conference was Rainforest Connection. Did you see this case study, either of you?
Yep.
So it's a really nice one. So it's a not-for-profit. They use old cell phones and solar panels. They put those in trees that are at risk of illegal logging. So up to 90% of the logging in the world is illegal in areas like Brazil and the rest of the world. So these are listening devices, basically, that they stick in the trees. And it's been around for a few years. And as soon as they detect the sound of chainsaws, then just the volume is high enough to trigger, and it sends off an alert. And so the people come in and stop the loggers. The problem was it was a simple like on-off threshold, like of noise level high, therefore intervene. So we worked with them on a predictive model where we could actually get a lot more insight into the sounds of the forest. And it turns out that the sounds of the forest start changing long before they fire up the chainsaws. So as soon as the people start driving to the forest, there's some car noise, there's less bird noise. And that was detectable using predictive analytics. So they could come in and give the alert much earlier in the cycle, long before people started cutting down the trees. So just a nice example of doing things faster and more efficiently. Okay,
I've got one more that brings joy to my day.
Go ahead.
Who hasn't gone to Google search and started to autocomplete something and died laughing because of what it thinks I want to search for? So,
right, but then, I mean, a lot of those are still useful, though. I mean, how many times have you gone and said, yep, that's it?
Yeah, right.
Data processing of quality data with appropriate algorithms is a must for predicting. How does the in-memory platform help? What's different about this than somebody just doing it with the technologies that have been around a long time?
Oh gosh, have you ever tried to run anything at capacity with like petabytes of data on a disk? Better wait. Really, so speed is the one thing. Obviously, compression is the other. You get it's almost 7-to-1 now from disk to memory compression, so you can put more data in memory than you could on a disk. But really, it's the speed, and a lot of these algorithms that we're talking about, they don't have to be real time per se, but a lot of times, they require a lot of horsepower to calculate. And so having that in memory and the data in memory with it is definitely a big gain.
And literally thousands of times faster. It reminds me of one project we did, predictive call center. They wanted, it was an electricity utility, they wanted people to be able to call in and get directed to the right service based on the number that appears when you call in. But they found that when they tried to prepare, they needed to get to the person in less than 30 seconds or something. But the predictive model at the time took several minutes to run. So it was just way too slow. They tried preparing the data in advance, saying, if this person calls, then we'll send them there. But that didn't work because they were often calling about something that happened a few minutes ago. It had to be real time. They had to do the calculation based on the very latest data. And within memory technologies, they're able to do that. So improving customer service and saving money. So that they send the person to the probable right service and give the customer service representative all of the information they need to answer the call correctly, whether it's finance or an outage or things like that.
I think to maybe put it another way, it's a pretty stark contrast. If you think about predictive modeling on traditional disk-based databases, it was a batch activity. You would write your model, you'd fire it off, and you'd maybe run it nightly. And what we've been able to accomplish is just what Timo, you referenced a moment ago: real-time predictions. Like the timeliness of data can now influence the timeliness of our predictive models too, and that's different. And that especially in healthcare or in just-in-time businesses, if you can integrate that on an appropriate set of your data, that's powerful stuff.
Let me just give you another couple of examples of stuff just very quickly. So one is taxes in Australia. They use predictive algorithms to figure out who's not likely to pay their taxes. And it turned out that they were able to strongly differentiate between two different profiles. One was the people that could pay but weren't paying. And one was the people that wanted to pay but couldn't pay because of personal circumstances, debt or something. And so they were able to give completely different treatment to those two groups of people. So ultimately, it was, yes, about getting more taxes, but also making sure that they were getting the more taxes from the people that should have been paying for it and helping the others get back on their feet so that they could pay more taxes. I thought it was a nice example. And then one more, Dutch utility used predictive algorithms matched with the historical data about this is in Amsterdam, their grid of pipelines and electricity conduits. A lot of their gas pipes are hundreds of years old and crumbling, and so they need to fix them all, but they can't fix all of them overnight. So they use predictive algorithms to figure out which sections of pipe were most likely to break, and then correlated that with areas of extreme danger, like schools and hospitals. So they were able to put all of that data together in a single model and prioritize fixing the pipe where, if ever there were an accident, that would help prevent the largest number of problems. So again, doing more with less and ultimately helping avoid the worst outcomes. But I do want to get on to the last topic, which is we said we'd talk about, which is obviously we've given some examples, and you can imagine many, many more. You're going to see a tidal wave of how organizations are going to be using this to improve business, save resources, and ultimately make us all better off. But with any powerful technology, there's also a potential downside. So let's talk about some of the things that we don't want to see people doing with predictive, or some of the barriers or dangers that might be out there. Eric.
I think fresh in the headlines, people are having little freakouts on things like AI and facial recognition and predicting criminal behaviors, right? We've seen in the news a couple of cities prototyping this, and the PR that comes with it. Maybe you sort of straddle the line between tech for good when people feel like their civil liberties are being trampled on a little bit. That's sort of Minority Report-y.
Yeah, and then I'm here in Germany. We've enacted very strong privacy laws recently that actually controls a lot of the data use. And I see that California has passed a similar e-privacy law that will go into force in a couple of years' time. So clearly these are concerns, and one way to do it is to make sure that there are laws to stop people from using too much of the data. But what else do you see?
Well, I think data and privacy and all that aside, I think we also have to be very cautious where this stuff starts to cross into our physical existence. So take for example, it was a couple months ago, that unfortunate incident in Tucson, Arizona, with the Uber self-driving car. It struck a woman and she was killed. So, whose fault was that? The algorithm's fault? Was it the human operator's fault? And did it matter what privacy laws were that were protecting that woman? She obviously was not protected at that point. So I think we have to be super cautious where these things, and I'm not saying I would love to have a self-driving car, let me say, just have come pick me up and take me around. But we have to be very careful where this technology affects a human's life.
And it's worth pointing out that the self-driving, all of the data provided from Tesla to the authorities indicate that cars using autopilot are way safer than human beings. So many accidents have been prevented, lives have been saved because people were using the autopilot. Yeah. The insurance companies have not been slow to realize this. You get a discount if you use your certain insurance services. You get an extra discount on your insurance the more you use autopilot. Which is a fairly good capitalist indication that they think that this is a good step forward. I honestly believe that as these technologies evolve, nobody will be allowed to drive cars. It's just it's too dangerous in terms of the number of people killed. But yes, so there is a dark side to these organizations. So so data privacy is a key one. And I think a lot of it is bad use of the algorithms. Whenever you touch on people's lives, you're basically using these machines to make decisions on our behalf. And the problem is that they are sociopaths. They don't have any emotions. They can't tell anything about the human existence. They can only copy patterns. So like a human sociopath, they can look like they're doing things in a very intelligent way, but since it's disconnected with empathy, it can create some big problems. And so there has to be controls in place. You have to think of ethics. Whenever predictive algorithms touch the human existence in some way, then you absolutely have to put ethics into any structured plan, as I'm sure HarrisLogic did when you were talking about your prisons. So the lowest hanging fruit is things like processing financial data or IoT data from a machine, right? You don't really have to worry about the ethics too much there. The more we start using it on things that touch society, the more we have to take into account. There has to be transparency, and there has to be a right of review. So if the machine is making a decision, there has to be a human being you can contact to overrule that decision. You can't. You should never be in a position where it said, "Oh, well, the computer said that, so that's it. We're done."
I think there's also in corporate America, as we start to find those opportunities to streamline operations, improve business processes, inevitably there are going to be the cases where it requires less people to do a job because we've found a way for machine learning to take that on, and there's that human cost that hopefully we find a way to offset and not displace as we learn more about this as a
one that automate. It comes up a lot. I mean, ultimately, it's not the first time the technology has displaced human workers. Obviously, in the past, it's generally worked out okay for the economy as a whole and people as a whole. Specific groups of people, though, do suffer. So we can probably see it's going to be the same thing this time. Jury's still out on just how big the group is that suffers compared to the people that benefit. The analogy I sometimes use is that we mustn't forget these new technologies allow people to do jobs that they previously couldn't do. The analogy I like is just way back when. You imagine you're in the general store and you're hiring somebody to work in the general store. They had to be good at arithmetic, right? You bought a whole bunch of stuff. They had to add it up so that they could figure out how much to charge you. Now, obviously, the till does that for you automatically. They just ring it up. So you can hire people that otherwise would have been awful at that you couldn't have hired before. You can hire people based on their customer-facing skills rather than their mental arithmetic skills. And we'll see the same thing with the powerful machine learning. It will allow people to do jobs that they wouldn't otherwise have been able to do, as well as eliminate jobs. The difference is we're just much better at imagining the jobs that will be eliminated than we are about imagining the jobs of the future. Right? We had no idea that somebody could make money being a YouTuber or esports, or there's lots of new jobs, entire industries that are being created around these new technologies. All right, final question quickly from Steve Ash. Will predictive analytics and modeling always be the domain of data scientists, or do you see these tools being effectively available to less trained users? What would it take to make these tools more easily adoptable by non-data scientists? So Greg, you're nodding and shaking your head.
Well, commercial aside, that's why SAP Predictive Analytics is such a great tool. You don't have to be a data scientist, especially the automated analytics piece of that. You just have to know what category you're trying to do. I'm trying to do a recommendation engine, or I want to do a correlation. And you feed the data through, and it decides out of thousands of algorithms which the best one is, and then you export it as SQL to SQL Server, Oracle, whatever. I mean, to HANA. I'm not a data scientist, and I can use this very very effectively. And there are lots of tools like that, and I think it's going to keep becoming ubiquitous. The old data scientist approach, I'm not knocking data scientists. We need them. They're super smart guys, and I think their propeller hats are really cool. But that process is very expensive, and it's very slow.
And all of the analysts agree with you. There's the topic of citizen data science is one of the hottest areas. These new tools that you just don't need quite as much expertise. It doesn't mean the data scientists go away and don't need them. They can just concentrate on the projects that are best adapted for them, while we can massively explode the opportunities for data science, for predictive analytics inside organizations to improve business, but also improve the world. The best run businesses help the world run better. Thank you for your time.
There it is.
Greg and Eric. And I'll hand over to you, Avery. Thank you.
Thank you.
Thank you, Greg, Eric, and Timo. A lot of great examples, good discussion. We appreciate you joining us this month. And thanks to everyone who joined us via the live chat on Facebook. We hope you'll join us. We're going to take August off from our live chats and go on vacation. And we'll be back in September with one on BW for HANA with Method 360. We hope you'll join us and have a great day.